So I've prepared a little pre-speech before the actual talk, basically because I'm so nervous, I should say, giving this kind of talk. As you might have guessed from my abstract, in case you actually did read it or did look at it, I tried to be less like, I didn't bring all the data we have, and I'm not doing a good job in sort of presenting and highlighting the great work my postdocs and PhD students are doing, because I wanted for today to step back a bit. And I'm actually doing this now even more, so all the proposed modeling or model that is in there, I'm not even telling you about this. I really want to sort of, it's almost like a bit of a science critical talk. So maybe it's good that it's not at the end of the conference, it's now here, and we can end on a more pleasant note tomorrow. So I'm taking a bit of a grumpy old man / psychologist perspective here, and I realized that a lot of the things I want to say are sort of have been said in better ways already by other people here at the meeting, or are entirely trivial to you guys because you all know them. But so maybe we can all at least emulate the position of well, we're also the sort of the flag holders of neural oscillations, and we go out there and publish stuff, and other people read our stuff and sort of like it and start to replicate it. And so in a way, and I think it's important that we sort of are aware of what we're doing there. And sometimes, so as an editor of a lot of speech and language articles these days, I'm coming a bit like the replicant in the Blade Runner, and I'm saying like, I've seen things you people wouldn't believe, right? So, and you can probably sympathize with that. So, let me start. This was the beginning. Now comes the actual talk. So, confession number one. Confession number one, I do love neural oscillations. And I guess that's true for most of you guys in the room. As I can tell from this graph, as you can see here, there's been a real surge in publishing stuff that is related to neural oscillations, synchronization, brain rhythm entrainment, EEG, MEG, ECOG, and speech language. I might get something wrong, but the overall picture is there. And you can see there's a sort of a rise, like, I don't know, 10 years ago or something. Let's put this into perspective, though, like for what has happened. If you remove speech and language from that search term, you get like 15,000 papers. And I haven't done some serious curve fitting, but it feels to me that some people were a bit faster than us, right? So this thing begins to take off here a bit earlier, and then later the speech and language guys think, hey, that's cool, let's jump onto that bandwagon. Like, that's kind of how you could interpret or overinterpret that graph. So my second confession is basically that I'm very worried about neural oscillations and what will happen to them, and where they will, how they will end up in the bigger theme of sort of science and the science of speech and language. So you could look like to our friends in the fMRI field and say, like, how can neural oscillations avoid the fate that hit fMRI activation? Like when you think of the last paper that you really loved, where there was like a big blob sort of popping up in fMRI, and you went like, wow, it's been a while, right? Like there's something has happened in that field also. So, and there's this famous quote. I have no idea who actually said it or who calculated. For me, it's that Russell Poldrack quote, which goes like, every voxel in the brain has by now been observed in more than 300 different statistical contrasts. Which kind of brings it to the problem that obviously it can't be very sort of specifically, IFG cannot be doing sort of working memory like direct. So we have a problem when we assign these direct links, and I think, and I will try to unroll this a bit for you over the talk, hopefully, that this is also a problem in for our field, where we don't have 100,000 voxels, but we essentially have a handful of frequencies that we keep sort of ticking and that keep coming back. So you could say, how can we, or how can the speech and language people in the room, we have this interesting divide here that some people are actually don't consider themselves speech and language researchers, but those of you who are, how can we jointly avoid to join, if you will, yet another party a bit late, this time the oscillations party, only to cash in on what I could consider comparably low-hanging fruits, like, oh, there's a syllable rhythm, and I see that syllable rhythm in the data, without solving any of the hard problems that I guess you speech and language researchers are actually interested in. I thought Lars gave a very interesting talk in this direction, I would consider syntax a real hard problem, and how to sort of really get at this. So you could say the brain is actually quite an epistemological minefield. So what I mean by epistemological, what do we actually know? What can we actually learn about the system? What have we truly learned about the sort of the construct, the thing we want to understand, be it syntax, be it attention. These are all constructs, right? And what can we truly learn from them, about them, if we have a condition difference, a statistical difference between two conditions in a neural parameter of interest, like be it oscillatory phase? And I will return to this a bit later. So what in all likelihood this will not mean is stuff that I hear a lot. I also hear it in a room like this because it's an easy way of speaking. We all kind of know that it's wrong, but we kind of say it anyway all the time. I think we say, oh, beta is prediction, or gamma is prediction error. Or maybe it's not, Nancy, now I learned, but kind of, you see where I'm getting at. Alpha, attention. Theta, that's memory. Theta, that's syllable entrainment, or delta, that's now top-down attention into A1. So we have top-down, we have attention, very, very, loaded words, actually. Delta is parsing. I'll go on for a while, I'll stop in a minute, but beta is top-down attention from frontal eye field, and so on. So you probably all agree on some level this is all kind of wrong, right? Or do you? Yeah, thank you. So a few questions that I maybe sort of want to exemplify today that I think should at least bug us a bit more are, a lot of this has already come up at this workshop, of course. Like, for example, the word oscillation even. Like, for a second, like, is there an oscillation to start with when we start talking about oscillations? Second, when we talk about entrainment of oscillations, is there actually entrainment? Is there synchronization at all happening? And if so, if we even establish 1 and 2, like for the third problem is probably the hardest, is this observation that we did by any means specific to the function? You could call this construct if you're a psychologist, you can call it process, you can call it phenomenon, under consideration. So to highlight this first one a bit, is it an oscillation to start with? I tend to say to a man with a wavelet, everything looks like an oscillation. This is something I learned the hard way in this little exchange with Odette. I kind of knew it, but I kind of fully understood it when we had this little exchange in Frontiers a few years ago. And particularly, a lot of the stuff I'm saying, again, is kind of true for people who sort of join the field and want to also want to analyze neural phase and stuff. This is then what happens often. They have an oscillation, but it turns out that this oscillation can, of course, and that's not new to anybody here in the room, I know, but you can, of course, just take kind of a white signal, and if you push it through a bandpass filter or through a wavelet, of course you get an oscillation, of course you get a beautiful phase that you can do all sorts of things with. Yes, you will statistically control for sort of entirely spurious results, but still, you have a phase series and you can load all these sort of concepts that you know about neural phase, you can pack onto this one, although it actually comes from a non-oscillatory process, and you just use a slightly different filter and you get a slightly different phase, of course. So here's an example for where this sort of gets a bit messy sometimes, because there are papers that I'm really excited about and that I really like. For example, the Sadley paper. And by the way, I don't want to, if there is a citation that comes up in a vaguely critical context, I also try to put up some of my own to sort of rather criticize myself. And in a way, this is also, I'm doing this here because I commented on this paper. They had an interesting point about sort of, they did something I quite liked. They took an auditory approach, but tried to relate it to stuff that Pascal and Nancy and Bastos and those guys have established, namely that maybe beta, alpha are sort of reflecting, I have to be careful what I say now, are correlates of some top-down processes, versus gamma is coding surprise or prediction error. That's all nice and true, but if you look at this power spectrum, in all honesty, this is a power spectrum I did from ECOG data, so it's not precisely the Sadley data, but it's ECOG data from A1. You can ask where in this is the oscillation. From a spectral perspective, this is a pretty nice 1/f spectrum, and indeed they're not the strong deviations from the sort of 1/f thing that you would expect that is a defining feature of an oscillation, right? So you could say, what's going on here? I'll return to this paper in a second. I even wanted to, this is also for entertainment, so I'm doing it a bit more on a fun level. So in some papers, you're not even shown anymore the time frequency plots. You're just shown a statistical result, or you're shown a statistical result of something like this. So in a way, you're happy already if somebody shows you the actual time frequency data that they had. What I find interesting about this looks kind of interesting, right? It could be elicited by a word or something, and then some cleavage like suppression, lower frequencies, maybe a bit low. It turns out it's actually from the honeybee. So it's not related to speech or to the human brain. Well, of course it is on some level. That's why my friend Nathan Weiss was involved in this. That's why they studied it. This is calcium imaging, it's odor elicited. It's kind of, Nathan was very envious because they take like one single trial to get this kind of picture. It's really beautiful data. But obviously, the system shares a lot of the features that you would expect also when you would play a word to a listener. So somehow the link cannot be so direct from a picture like this to the construct you actually want to study. And if I can bore you a second longer about these sort of statistical problems, if you now add to the mix what I would call the mixed blessings of the permutation cluster test, you get a bit into trouble, because what you can do with a cluster test is kind of, and it's really used a lot. We could have a graph only for the cluster test paper itself, right? It's been cited heavily, and we're all use it, and we all probably love it to some degree. Why do we love it? Because it gives us control over the false positive error, right? Over what we call type 1 error. That's nice. But it also encourages really like exploring your data without any sort of theoretical background. It's not particularly true for what we discussed here today and yesterday, because this field is quite coming with ideas and concepts still that they want to test. But generally, you have two conditions. You compare them. You sort of just look into the data, you go across all channels, all frequencies, all time points, and something pops up as a cluster. And then you remember, oh, why we have to control the type 1 error? Because in our field, you could say our field, or psychology as a whole, is pretty obsessed with the type 1 error. So much more than about sort of having the power to find something, we're worried about this. So if you find something that apparently survives, you're sort of good to go. And it might even still be spurious. You just might have sort of won against the type 1 error. And off you go, and you might write a paper about a time frequency result that is, well, maybe not so grounded in theory, nor in the neurobiology, actually. So that's more a methodological side that I'm a bit worried. So this is hopefully the past, I would say, that somebody in a paper, I mean, there was also a topography, but there was like somebody finds a theta effect, puts it into the paper, makes a claim about it, writes 3 paragraphs in the discussion about it, but it's not really clear how it actually relates to the construct we want to study in this paper. It's called theta band because that's where it popped up. Was it an oscillation? Where is the spectrum? We don't know. So a first thing, and this came up in this workshop already, and it's good here, but it's not so great in all the EG, MEG papers. Convince me, convince the reader that there is an oscillation to start with. And I think this, of course, I always sort of envy Peter when we talk about these things, because of course there's an oscillation. I can see it with my bare eye in the data, you know? So here in his spontaneous recordings, and he showed this yesterday explained it much better than I can do, he shows that there is a delta oscillation to now work with, and so the speech and language people could ask themselves whether this would maybe be great to first establish that something like this is there via the spectrum, via spontaneous data. And this is from Flavio Fröhlich's work, which I also quite admire, where he looks at a correlogram, basically, so more a time domain, cross-correlation, autocorrelation analysis, and finds these sidebands that are reflections of some oscillatory signal in there. And he nicely shows how he can push around those sidebands with his TACS, for example. So why not more of this? This is basically what I'm wondering myself. In a way, what Joachim yesterday said, and I'm thankful that he already established some of the more critical concepts that I'm now only extending here. In a way, papers like this, I do consider sort of future. They, for example, they try to operate as soon as possible in source space to at least avoid some of the typical problems we're having with interpreting topographies of oscillatory activity. And they're then sort of coming up with these spectral signatures. They have been sort of the 1/f trend has been removed, and we can be kind of confident that these are actual neural oscillations. What I find kind of ironic in a way, and I'm putting ironic here with a footnote to this quite amazing Krakauer Gazanfa purple paper that recently came out. I think the best evidence we're actually having that these neural oscillations do play a role is that we see behavior oscillate, which is without the brain, right? This is kind of old school. These are behavioral experiments. They were impressive in and by themselves, and they were actually nowhere near a EEG or MEG in the beginning. So I list a few of them here. I sort of just pulled out one figure from the Fiebelkorn paper where attention over time is, I would say, oscillating between attended and unattended location. We talked much more about this morning in Pascal's talk. This is just one data slide I've put in because I also wanted to highlight some of the things my guys are doing. This is from Malte Wüstmann. It's an honestly also a bit of an accidental finding, but we found that, for example, the memory for digits is affected by a stimulus, a sentence that comes in that you're actually supposed to ignore. You try to remember these digits to reproduce them later. This is really like exhausting your memory. And here comes a sentence. And we jittered the sentence basically for reasons of data analysis. But it turned out that this jitter gave us a really beautiful, gave us two oscillations basically. It made, if you will, the behavior oscillate. And it made the evoked response to the sentence oscillate. Just one thing. And to also show, and leading us over to the entrainment problem, a figure from Elke Spark and an Olis paper where I think also we have some reasonable evidence that detection or, I can't fully remember whether it was discrimination or detection, I'm sorry, but that behavior actually oscillates after the end of an entraining stimulus. Neither of this evidence was directly related to speech and language. I think honestly that last data to this morning was maybe one of the more direct attempts to bring this approach to the speech and language field directly. So the second big question is it entrainment we're witnessing, even if it's an oscillation? You could say, does it matter? It's just a word, right? But I think we have a joint responsibility to not worsen the signal-to-noise ratio in the field by sort of mixing these words up and using them either way. That's why I developed a bit of an obsession over this recently. I could show you, of course, the video with the metronomes, right? You've all seen it like many times, and all the iterations of the metronome video metronomes. So I'm showing you rather a video of what is, which I also quite like, and you probably also know it, but it's not entrainment. And I think, correct me if I'm wrong. So you give an impulse, the machine does something, right? Maybe this is at least an oscillation, but the question is whether this is entrainment. Sorry, the video starts again with, you can skip that. It's kind of redoing, it's replication, very good, right? It's built the same machine, it's replicating the problem. But at least now they're doing something very interesting. They turn this into an oscillator, I think. I'm not a physicist. And there are many more versions of these. You can watch these, like people build crazy machines from it. So while we try to study something useful, people love... Is that an oscillation, Nancy? Yes, okay, thank you. So, but how to define... But was it entrainment? I don't think so, because it was just one... This thing built one oscillation, right? So how to define entrainment? You could turn to sort of the pros in the field, and you could turn to this great book by Kurtz, and Christoph will explain much more about it tomorrow, I think. And it's defined, of course, as the adjustment of rhythms. The adjustment, so you need pre-existing rhythms of oscillating objects, so you need in principle at least two oscillators before you do anything, due to their weak interaction, which is actually also would actually preclude even these sort of hard phase resetting things, if I get this correctly. So, but by this definition, what I would call, and I would call this definition the entrainment in the narrow sense, or in the strict sense, or in the physicist sense, a lot of our papers would have to go a long way before they should be using the word, because they would have to establish that there is an oscillation, that the stimulus oscillates, which is kind of what we rarely have, I think. We have regular stimuli, and we would have to establish that either of them actually adjust the rhythm. So what I really like and what I just wanted to propose to the speech and language field is to come up with smart ways of, for example, using this, what Christoph Herrmann and his student recently used, a concept also from physics, the so-called Arnold tongue. It's really an interesting idea that you say, if I have an oscillator that has an eigenfrequency, for example, alpha, it's maybe one of the most non-controversial oscillating signals that we have in the human EEG, MEG. If you stimulate that frequency, the closer you are to the eigenfrequency, so to speak, of this oscillator, the less energy you will need to drive this thing. So you correct me if I'm wrong, right? But I think this is what you guys tried here. So I can sort of entrain this alpha oscillator like 3 hertz away, but I will need a lot of energy to do so. And on its frequency, I will not. So I don't know how we could do this in speech and language, but I really like this concept. And I think and Christoph used it in a much harder way because he used it in the visual domain where you try to dissect whether the alpha oscillation and the visual evoked responses are sort of the same thing. Actually, also a hard problem, but this was, I think, a helpful thing here to do. So if we, for now, define entrainment in a rather liberal or broad sense, we could say, okay, fine, I've given up. We use the word entrainment also in our field, but then we have to be, I don't know whether we should do that. We could call it entrainment in a broad sense. There's a quasi-regular thing in our stimulus. There's a stereotypical response in the brain. Think of this little machine. And then we usually have a spectral signature thereof in our data. So for example, just an example, the sort of methods that Nye with Jonathan Simon has used a lot, that Elana in her data is using, that Ad Layler is using to I think great effect, is in strict sense not entrainment. What you do is you find a linear function. Ruffin also explained this just much better than I can. Sort of that gets you from something in your stimulus to something in the brain, and a lot of people are kind of cool with calling this entrainment, and I would call it entrainment in the broad sense, if you want to use that. But we're all perfectly aware that this system, like this little machine, is basically could also well be a series of stereotypical responses, of evoked responses, essentially. So I just wanted to put here out in the room to ask ourselves whether the entrainment, well, let's call it the entrainment metaphor, is actually helping or hindering our understanding. It can be a bit of a dead end, I think, if we say we need entrainment necessarily to sort of prove our concepts or something. And even if you, for example, in syntax, I mean, this has come up at the workshop also. Is syntax really like regular enough? Is this steady enough? Aren't these rather these sort of short bursts that are regular? Is this all commensurate or not with the entrainment concept? I'm not absolutely sure. And even if so, you could still wonder whether entrainment to rhythms is always helpful. I think there are a few nice demonstrations by Leon Duell in J Neuroscience last year, and Molly has a paper, Molly Henry, who's also here, my former postdoc, she has a paper coming out these weeks where we're also, I think, seeing that entrainment to a rhythm is not necessarily a good thing, depending on the task that you actually want to do. And I think you could think of listening situations, speech situations, where like going with the rhythm is not necessarily helpful if you're in a sort of a hard or picking up on something situation. I don't want to ruin everybody's sort of mood by going back to something like this, but I'm doing it anyway. Probably David would say the case is settled with the syllable, but there are people like Fred Cummins or phoneticians who say, well, you guys, with your envelope and the envelope reflecting the syllable and the linguistic content of the syllable is even not so straightforward. What Cummins shows in this little comment it's actually a reply to Peel and Davis, is that this is the waveform, this is the amplitude envelope that we mostly work with. This is the often referred to jaw movements, where everybody also like thinks, there's also like theta, and yeah, nice, but it actually looks a bit different. So to be fair, this is the first eigenvariate of the jaw movement, but still. And this is what a linguist sort of scripted for this being the syllables. Probably this is still rhythmic and it's still kind of theta, but I just want to kind of raise the awareness that it's not necessarily an isomorphism between going from the envelope to the jaw to the syllable, right? It's not necessarily all the same thing. So I think what David would agree with maybe is this call by Cummins then to say what we really need is a formal model that would, and this has also come up here from some of the linguists, that you also use all the knowledge that a listener also has, basically, that is not in the rhythmic domain, that is not in the stimulus. How can we build this into our models? That's really a question. And he finds it like utterly reductionist, basically, to say oscillators, speakers are the oscillators, hearers are the entrainers, and this ignores, obviously, a lot of the complexity. I think what I'm trying to say here is to us brainers and engineers, brainers is not an English word, I made this up, but maybe we could respect a bit more the actual complexity of language. That's all I'm saying. And so the last point is if you have oscillations, and if they are entrained, like, is it by any means specific to the function you actually want to study? And you could ask yourself, of all the beautiful, well-crafted data we've seen here already over the last 1.5 days, was there a single thing, a single data point, a single effect that you would, that anybody in this room actually would get up and would say, yeah, this is really specifically contributing only to speech and language? Probably that's not something we have to discuss about. Probably we mostly would agree on that this is not the case, but it was one of the questions that Lars and Alessandro posed to us or that was posed in the invitation, like, do you think there is something specific? And so this is kind of getting a bit like basic, but I still find it, I have to tell my own brain every time I do these kind of analysis that this is actually a true observation, only because I observe a brain rhythm. This does not mean that I observe the construct I think that is reflected by it, right? I mean, it's kind of a no-brainer, a Bayesian no-brainer, but I thought I'd put it here anyway, and I even wanted to put it in sort of psychologist lingo, which is the latent variable, the construct you want to observe, the likelihood of having, or the probability of having that observed because you measured something, is not the same, the probability of actually seeing that effect if your latent variable is sort of in effect, if your construct is there. I'm running out of time, but I have another 4 or 5 minutes maybe, so I would like to use them on going a bit, I stay on the same sort of critical, grumpy old man mood. I hope you're enjoying it. I'm really, when you start thinking about the words we keep using, also in this room, it's kind of, it's getting hairy a bit, like mutual information or information in general. We use this a lot as the argument. This is kind of the next, after you're done with the activation thing, comes Krieger's Quarter 2006, and everybody says it's about the information that is in the signal, not the activation, right? Absolutely true. Problem with that, though, is that information itself is a slippery metaphor. And we should at least ask ourselves how plausible, that could be translated to how much variance do you actually explain, and how feasible is it that what you decode from the signal, what you see in the signal, what you can recover in information, how much does this actually relate to the overall process? How much does it contribute? And I'm going back to the Sadley paper for once. Again, I really like the Sadley paper because it had a nice sort of computational engine in the background running. The stimuli were designed in, I think, a careful way to separate parameters of prediction, prediction precision even, and of surprise or prediction error. And they find these little clusters and off we go. But in terms of the actual correlation values, and these are actual Pearson correlations, this is, of course, super tiny, right? This is like less than 1% of variance in the overall brain activity we have now understood, now that we have this. And only going to the information theoretic measures, only using transfer entropy or mutual information, I think does not change this. It only frees you from talking in terms of R squared, what everybody understands, and you're talking in nits and bits, but it still means that it's not a lot of information what you're actually bringing there. And for worse, we can say, only because we can decode from an area that the information is in there. Does this mean that this information did actually get used in another sort of downstream area? Is it, like, on a neural level, actually something that is meaningfully used? And this is what I enjoyed most about this meeting here, are, of course, these aspects that Pascal or Nancy or Peter, so the physiologist, can sort of bring into the mix, because we're, of course, pretty lost with EG, MEG there. Okay, I gotta skip a few things. To sum up, what is the problem? The problem basically, I think, is we're designing experiments, and what we're actually doing is we're comparing conditions of experiments. They have been more or less carefully designed to isolate a construct. This is how psychology operates. For example, rhythmic versus non-rhythmic. So this is on the level of what you actually do. You then want to talk about what I call the dollar construct. It's of course the variable, but it's also maybe the $1 million construct that you want to crack, like syntax. But this is something very wholesome, of course. This is something that happens on the level of humans or between humans. And it's a phenomenon. It's nothing that can be easily reduced, of course. We then look into something like spectra. They are actually living in MATLAB, so to speak, right? They yet another domain. And sort of the hinge or something, the pivot, you would say, for us are the neural oscillations, sort of on the brain level. But we have a lot of problems with doing here, and with sometimes forcing analogies that are not really there. I think I've tried to highlight some of these, that going from a, just because there's a bump in the spectrum does not mean that there were oscillations, for example. But another hard problem, I think, is even if you have these oscillations, how do they actually relate to this level? So you could say it much more nicely with the late George Miller, who wrote, probably must have been the last thing he did in his life or something, write this, he's dead, right? Yeah, okay. Write this paper, where it's very clearly all in there. Like, if you pursue only biological explanations, and I would say that this is what we're doing at this workshop also, we're only pursuing, mainly only pursuing biological explanations, the actual psychological phenomena will necessarily remain, at least in parts, unexplained, because it's a different level of descriptions. So now you have spoiled us the mood. Jonas, do you also have any suggestions? Yes, but I'm out of time. I have a few. Now my speaking time is over. Now I'm going off the... Okay. Let go of the sinusoidal metaphor. Why trivialize it with a bank of oscillators if it's actually a complex spectrum that together modulates excitation? Skip the rhythm entrainment metaphor where it's not helpful. Ask yourself whether it's helpful for what you're doing, and learn to love the time domain again. Like looking into the time domain, we're currently exploring some neural irregularity measures that seem to encompass, like permutation entropy, that seem to encompass a lot of oscillatory activity also. I'm not saying they are that, but we find it useful to sort of, because we leave aside sort of the wavelet representational problems partly, I think. So speeches and languages, you just should respect the brain's complexity just like they should respect the language complexity. And don't give up on nice psycholinguist experiments. I think that's really, biological data are not inherently more fundamental or more meaningful than a well-designed psycholinguistic experiment, if you want to study language, I think. Yes, the uplifting note I skip. I think we're doing a lot of things right. I think we are actually operating in a way that we're trying to. We go, guys like Bechtel would say, the actual mechanistic explanations, they go, of course, across the levels. And so it's all about also recomposing it. And I think a lot of us are trying this, but there's maybe more to be done. I have to skip all this. I do my own poster session down there. You can come and I'll show you those slides. I just basically, but I can spare those because I'm really trying to wrap up a lot of the things that I feel are emerging. I think there's a lot of agreement that the frequency, sort of the register, is actually, can be maybe subdivided in a meaningful way that is or that does make sense. So, but I will not even try to comment on this now. To sum up, Lars and Alessandro had asked, do oscillatory timescales provide the adequate granularities to capture language-speech processes? To me, granularity is not an issue here, I think, unless we touched on it with the replay thing, then it got a bit interesting. But I generally think the granularity is fine. I'm less worried about the brain's timescales. I'm more worried about how we use the timescale rhythm metaphor for the processes of interest. What specific insights have we gained on neurobiology of speech? There I'm quite pessimistic, just for the fun of it, for today. It's sometimes fun to be pessimistic as a scientist. I begin to understand what neural oscillations are and what not, but I'm less sure that we actually have understood yet, because of our endeavor into neural oscillations, that we have understood so much about the neurobiology of speech. And is anything of neural oscillations specific to processing speech and language? A German saying would be, I will eat a broom if so. So I don't think so, because language is a virus from outer space, as we know. So it came and there was this system and it hijacked this system, but it is unlikely to find something very specific in there. So take home message, let's keep an eye on our language, on our scientific language, and how we infer from our data. Thanks for not shooting the messenger.
Thank you, Jonas, for your spirited Jeremiad, which I feel, certainly addresses my relentless naivete about the topics, and I will try to do better. Let me just tell you, there is a little bit grounds for optimism. I mean, I'm not, so you're actually a young man. So you still can make some positive contributions.
I thought it's more fun if I take like a strong stand.
My perspective from a much older man than you, that there is a point to do this. Namely, we might actually learn something about how the brain works, or we might learn something about how language works.
But do we know about which one we learned? But you're
worrying about that we might learn nothing. And I also worry about that, but I'm a little bit more optimistic. I think we might actually learn something. But your points are well taken. And
you're a psycholinguist also by training, or a linguist. Do you
No,
I
own my naivete, but I also am willing to actually fight for it.
Okay.
See, for the positive proposal.
Okay.
But so I think there are going to be lots of comments. Nancy was the first one. Ola was the second one. I have a range of comments. Nancy, you go first.
I wanted to say that I loved your talk.
Thanks very much.
And totally agreed with it. So I want to start with what is a neural oscillation. I think it is not anything like what's in the normal oscillator literature, which certainly it's not sinusoidal. I don't think it's an it. In other words, what we normally see is a lot of dynamics out of a whole lot of cells, which, if appropriately filtered, have some subset of cells doing something that's quasi like a rhythm. So that's the object that we really have to be thinking about, rather than something that's a much cleaned up version of it. Because we don't have any clean, except maybe in central pattern generators, there's a pretty clear traditional oscillation. So what do you do with that? I agree that the notion of entrainment is probably the wrong one, because the whole theory of entrainments in the traditional literature is if you have an oscillator and then you have something else that has a periodic input to that, depending on the structure of the oscillator you have, which is usually thought to be one-dimensional in the sense that it is phase and nothing else, which is certainly not what we have with a neural oscillator. How can you make that external outside thingy influence your one-dimensional oscillator? We don't have that. So that's the reason why I think that entrainment is probably not the right, asking whether we have entrainment is not the right question. So let me tell you what I think a right question is here. We have a whole lot of different parts of the brain, and they're getting a whole lot of inputs from a lot of different parts of the brain. And we barely begin to understand how it is that when A1 gets some input from prefrontal cortex, what does it do with it? Now, the input can be coming into a variety of inhibitory cells. It can be coming into different excitatory cells. It can be coming in at different frequencies. It can be coming in different modulatory states of the... So one extremely important question, and this is not just about speech, but it's understanding every form of cognition, is what does a given part of the brain do with its inputs? And that's in the spirit of entrainment, but it goes so far beyond entrainment because there isn't a simple idea of, I'm going to make you do that. It's mushy. And we have to allow ourselves to pay attention to that mushiness. And So even with the concept of communication through coherence, which I like a lot, and I think has been very useful to the field, one needs to go way beyond that because the inputs are, I mean, coherence is certainly important, but the inputs have some structures and the outputs and the target has some structures and everything is modifiable. And that whole complexity, I mean, speaking of the paying attention to the complexity of the brain, that whole complexity is at the heart of how this communication is happening. So I have a lot of other points to make too, but I simply wanted to start
You can take
with,
another turn later.
Me?
Yeah, you can.
Oh, okay. What else was I
how many
saying?
more points do you have?
Oh, I don't know.
There's
I'll
no
think
discussion.
about them when
Okay,
I
think about them.
come up.
In the meantime, Oleg gets a turn, and then we can go around and
Okay.
around. Is there? I don't know. Was there a response you were hoping for Nancy?
I hope not. I was just listening hard and enjoying it. And
Okay.
So I mean, these are all well-taken points, but I also feel this should just serve to inspiration for us to up our game. And I think there's a lot of things also to be excited about. So you rightfully.
I totally agree. Think of
Yeah.
my first slide, please. I love
Sure.
neural oscillations. Important.
Yeah. I mean, so for instance, you mentioned people are a bit tired of the functional MRI blob, right? Which is correct, but there's also been a lot of development in the fields where people are embracing multivariate approaches like representational similarity analysis and decoding approaches that allows you to look into the representation. And it's my feeling that also for EEG and MEG, there's a lot of that work coming that allows us to look into representations themselves. And in particular, when considering oscillations, then that becomes very important because supposedly all what oscillations are about is to organize computation in time. And in order to understand what they're doing, we need to embrace the representations better. So I think the multivariate approaches hold some promise for that.
I
But
think,
also, so just,
No, sorry.
I'm almost done. So, but also the fact that there's, it's also my feeling there's a lot more crosstalk between animal and human researchers. So that also allows us to think more at the mechanistic level and let ourselves be inspired and interpret our data based on relating, say, spiking data to field oscillations, again, to understand how representations are sort of joggled by oscillations.
Can I make two very brief remarks? I have very short memory, so I have to remember. So the first one was information. I think what we're witnessing with this going from activation, so it's there, wow, to information, oh, there's something in there. I think what this sort of highlights, and now that if I came across as sort of disappointed by that approach, or if I highlighted a paper here that expresses this, I think what it only shows me is this sort of fractality of not knowing things. Like you go deeper and deeper. Like after a first excitement about information or decoding stuff, I think it's only fair to say, what have I actually learned? And I think this is something that the fMRI field goes through, and I think we may be following along. So I just find this interesting to see this. And the second thing is, that's where when the physiologists and the speech and language people, like in this room, talk to each other, I think it's dangerous to use terms like entrainment or an oscillator. It can be like short-circuiting. It can pretend understanding that is maybe not there because Nancy means obviously something different than entrainment or than a language researcher maybe for him or Odette thinks of entrainment. So all I'm doing is like highlighting that as a scientist, you cannot take any of those terms sort of for granted. I think you have to take them apart again and see what you actually mean by it, like Nancy started with entrainment.
But that's our problem, right? I don't think the brain cares.
No, the brain does not care, but we care about the brain, so.
Yeah.
It's going. Yeah, it's almost sociological and historical perspective, I have the feeling, so there was the opening of this workshop was by Angela Federici, who just left, and she was talking about paradigm shift. Mm-hmm. And this term, as probably you know, was used, became popular after Kuhn, and about scientific revolution. So I'm not sure that we are really into a scientific revolution, but maybe what you are criticizing here is a paradigm shift. But what Kuhn says, that at least from a historical and sociological perspective, is that what is important is there's no ground truth. I don't think no one here is claiming that there's no ground truth. And so it doesn't make sense to claim that there is ground truth. It probably doesn't make sense to criticize that there is no ground truth, you know, and say, well, you all believe and so there is something truth. Because I don't think anyone is claiming. But what is important is if we have the chance of being into a paradigm shift, which I'm not sure, but you seem to be claiming that more than me, then we should go as a community towards the end and doing what you're suggesting at the end. So precising, redefining, precising all the terms. So the nice thing is to have a new perspective, a new vision on how things may work, but which doesn't necessarily mean that this is going to be more true than what people have been showing before. So that's all.
I think the very modest goal of my talk, despite its non-modest sound, was that that basically I'm thinking a lot. What you witness when I show these sort of translational problems between psychological constructs on the one hand, measures on the other hand, oscillations. What I try to highlight is probably my own sort of realization of these problems. I'm speaking like this person on this slide. I'm the person who says like delta is top down. It's just a shorthand. It's great, right? It works in a lot of situations. But I'm getting more interested in what it does to our field and whether I'm thinking about how can we improve the SNR in our conversations. I think this is what I admittedly have not offered much answers in this direction, except for encouraging to let go of some metaphor if it's not helpful. But other than that, I think yes. Stop here.
No, I mean, there's nothing wrong with careful conceptual analysis. Everybody agrees with that, and actually even philosophy is not so bad to think carefully about our problems. I think your points are well taken, especially in the beginning. The kind of reification of how we talk about things is actually a good criticism.
I will just maybe to say something that David would like to say. You know, he's been talking a lot about computations as opposed to psychological concepts, and I think that one of the problems that you're talking about oscillations as if that would be the culprit. We're trying to assign a function to oscillations, and you say the mapping is going to fail because the psychological construct is not going to, map one-to-one onto the brain, which I cannot more than agree. But I could say that it's probably the problem is not necessarily in the biology part; it's in the psychology as well. Our concepts are just way too big. We need to start thinking also about computation, so linearization today when Ole was talking about...
We might be witnessing something like this for attention, for example. I've been thinking about this a lot. Maybe attention is like, with everything we know now about sensory gain and stuff, and I think I'm granting this, that if I hear a hardcore neurophysiologist talk about attention now, I'm not thinking anymore, you're misrepresenting the psychologist's concept of attention, but you're actually much closer to having a good working definition of attention there. So I agree with that, yeah.
But I think the invitation for us psychologists is to really think deeply about what we are studying. And again, I don't think that syntax is going to map one-to-one into the brain. I'm going to think really hard, like what are the operations behind that? And as long as we don't do that, it doesn't matter with entraining or with, I don't care about which, oscillation. It's the psychology that is also lacking there, the part list.
Okay.
I just wanted to comment on one of the questions that you tell is a big one, which is, are oscillations specific to language? I think the beauty of the mission we have is to understand why oscillations that are absolutely not specific to human, absolutely not specific to language, contribute or determine language. This is precisely what we have to do.
No, I'm absolutely true, but I'm not sure that this is always done like this in the field. I think I think there might be a cognitive bias towards still claiming specificity of a data finding. But I totally agree, and I think actually I think this is most people in this room can agree on this, that this is the beauty of it. Yeah.
turn it on, though.
Yeah, I tried. Okay, so I entered this whole field relatively late, right? So I'm a linguist originally, and I have a feeling that the psychologists are super intrigued by the idea that cultural systems are kind of totally symmetric and isomorphic with what's going on in the brain. And I think that's one of the reasons why everyone loves neural oscillations, because they kind of seem to be a one-on-one mapping to cultural systems, right? Music and language, it has all these different time scales, and they're there in the brain. So like the inside is the outside, and now everything is cool, right? And the evolution and it has worked towards being that way. But I mean, you as psychologists, you already have to understand the brain, right? And you're worrying a lot about how the system works and blah, blah, blah. But when it comes to quantifying the cultural systems, and that was the question that came up so many times, like, oh, how long is a phrase? How long is a word? How long is a syllable? And so on. It's maybe a job that the people in this room, you shouldn't be doing that. I mean, maybe you should hire linguists again that really sit there with their computer and just count phrases and measure syllable length and stuff like that, right? Because as long as we haven't done that, I think we're not really getting out of this problem, right? Because every time you build a paradigm where you have irregularity built into it, someone will come and say, oh yeah, this is not natural. And then someone will say, oh yeah, but you don't know what natural is. And then we all stand there and go like, okay, what are we going to do next? Oh yeah, someone should quantify that. So, but that's not the burden that should be on your shoulders, I think, right? You have a hard time, doing all this technical stuff, and the analysis methods are complex, and the acquisition methods is also so highly complex, and that's what you understand. You understand the brain, and maybe better than other things. So, but there's people who could understand it, and so maybe I was just like looking, and I don't know how many linguists are here. Can the linguists raise their arms? You see, it's 5 people, 6 people or so. How many?
So are you saying we should have a mentoring program where every neurophysiologist has to hire one linguist, kind of?
Maybe, I don't know.
That would help.
Or the other way around, depending on where the funding goes.
An intro course. Oded and then Nancy.
So how many engineers are in the crowd? Well, okay, because you see, I think that I'm not going to apologize for Jonas on anything that we do. I think that in the crowd here, basically, we have experienced people that are leading groups, and you have people that are starting their careers. And I think that the mentors should concentrate on teaching and conveying how to do research in a responsible way. And the students or the young blood that is pressed hardly because of the politics to publish papers, and sometimes they do shortcuts. Just pay attention and do good job. Follow the practice of checking what you do, making sure that you are reporting it right. And if you are going to stick with it and use your tools the right way, understand the tools that you use, and then again, the mentors should teach them how to use the tools, what is the meaning of the tools that you use, so then things will go right.
Here, yes. Nancy.
So we've been talking about oscillations in the brain and speech, and underlying a lot of this is about what do oscillators do? What are the functions of oscillations? I think that in order to understand what the potential functions of oscillations are in any part of cognition, we have to really think hard about what kinds of computations can be done with oscillations. And I gave a few examples of that in my talk. I don't think that can be done in the absence of thinking about cognition. That is, you put a whole bunch of modelers in a room and say, what do oscillations do? And you'll get a whole bunch of things that are completely irrelevant to what happens in the brain. So I think that one has to phrase the questions of what kinds of computations can oscillations do in the context of very specific cognitive problems. And I think that it's not just what oscillations can tell us about speech, but we're going the other direction. What can speech tell us about oscillations? And so by making these measurements about these quasi-squishy, not quite oscillatory things, I think we're getting to the point where we can ask very specific questions about how inputs with certain spectral properties can then affect their targets. And then that becomes the basis for a theory about what oscillations, what kinds of computations can you make with oscillations. So I feel very strongly that you have to have groups like this in which the specifics of what goes on in cognition is front and center before you can have any kind of theory about what oscillations do in the brain.
I think
that should make the experimentalists happy.
Nobody can plausibly disagree with that. I mean, be careful. You have to be careful about both sides of the.
But I mean, I raise it because there may be no disagreement here, but there's a whole lot of disagreement in the computational community.
Well, let's put it this way. There's controversy, but no issue. Nina? And then we're going to end pretty soon because posters.
Yes, okay. That was a hint. Stop before you start. So thanks for a provocative, but I think appropriately provocative talk. So actually, I wanted to talk before you said your thing, but maybe I can continue what you said with a few examples. So basically, why do I value a meeting like this, for example? Because from a psycholinguistic perspective, so I think we are aware now of the, there are a few cases where we know exactly what we want to do to build a sentence, for example. One thing you need to do is to be able to have a sentence that's like John kissed Mary and figure out who, have those two objects at the same time in your working memory and yet not confuse John and Mary, not John and Mary per se, but about, who did what to whom, right? So here I am with my, very, I think, well understood kind of, linguistic question, looking at you, and I guess, now maybe you'll understand my question better. By you, I mean people who do animal physiology. If you tell me, so I need a mechanism of representing two objects in working memory without confusing them. You have that mechanism. I think, I'm looking at Pascal right now. So if that's the level, if that mechanism is carried through oscillations, and I think that's my reason to be in the oscillatory conference now, because it seems to me that the types of mechanisms that are useful, or at least some of the mechanisms that are useful for linguistics, are seemingly carried through, through that bad word, So I think that's maybe a more, so if we can continue, that type of dialogue, maybe the kind of worries that you have at the moment will lessen.
That would mean I can next time also come and give my data talk and show you all the beautiful data we're also having.
Fair enough, yeah.
Taking a picture of this. Thank you.
I think we're coming. So let me, permit me a closing remark as the addressee. I think I want to amplify with something you said at the beginning, which is a very good reminder for us all. And I think I'm happy that you raised it, which is we have to be simply very, very careful about kind of reifying the responses we have. So they are shorthands, right? So when you say delta is this and beta is that and theta is that, I mean, we as long as we're aware that those are shorthands for internally structured, complex set of representations and computations, I think then we're safe. It's when we take it on board as a monolithic conceptualization that we get into serious trouble. And I think it's good to sort of point out that the conceptual care is absolutely required. So I think we should thank Jonas for getting our blood pressure high. And